Hi everyone. Today we're going to be completing our notes on the law of sines ambiguous case. I want to start with this warm-up with triangle A, B, and C, where we are solving for the side length B. We are given side length A is 14 centimeters, and that is the side length across from angle A. We're given angle A, which is 38 degrees, and we're also given angle B, which is 58 degrees. We want to solve for side length B, which is across from angle B. We can use the law of sines to solve for B, so we set up the equation, the sine of A, which is 38 degrees, over side length A, 14 centimeters, is equal to the sine of B, which is 58 degrees, over side length B. To solve this equation, we cross multiply, so we get B sine of 38 is equal to 14 sine of 58. Dividing both sides by the sine of 38, we get B is equal to 14 sine of 58 all over sine of 38. Okay, this would be the exact answer. If we want a decimal approximation, we can go ahead and take out our calculator. So take out your Inspire and open up a new document, and we're going to type in that expression. So we have 14 sine of 58 over the sine of 38. So we have 14 sine 58 over sine of 38. And a decimal approximation, we get about 19.284. Okay, so the side length B is 19.284 centimeters long. All right. Now let's talk about the ambiguous case. We can use the law of sines whenever we have angle, side, angle, 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 side, or side, side, angle. In this instance, we had angle, angle, side. We had angle A, angle B, and then side length A. So we had angle, angle, side. We could use the law of sines. But, if we have angle, side, angle, or angle, angle, side, there's exactly one unique triangle solution, right? In cases where we have side, side, angle, that third case, there are possibly 0, 1, or 2 unique triangles. The number of unique triangles is determined by side, side, angle is ambiguous, right? So there are instances where we have the information, two sides and an angle in this orientation, side, side, angle, and it's unclear whether or not we have 0, 1, or 2 solutions. So we need to use the law of sines to determine the number of solutions. So let's consider the first case where no triangle exists. So given triangle ABC where the measure of angle A is 30 degrees, side length A is 7, side length B is 16, find the measure of angle B. So to set up the law of sines, we have sine of A over A equals sine of B over B. So sine of A is sine of 30 degrees, and then over side length A, 7, equals sine of B. Well, we don't know what B is. That's what we're solving for. And then over side length B, 16. Cross multiplying, we get 16 sine of 30 all over 7 is equal to the sine of B. Or at least, multiplying both sides by 16. And then, in order to get B by itself, we have to take the inverse sine of both sides. So we get B is equal to the inverse sine of 16 sine 30 all over 7. Okay? Now, at this point, you could take out your calculator, but I noticed that we can simplify the argument of the inverse sine right here. I noticed that the sine of 30, that's a value that we know. This would simplify to the inverse sine of, well, we have 16 times the sine of 30, which is 1/2, and that's all over 7. And so we get the inverse sine of 8/7. Okay? If we plug this into our calculator, so take out your Inspire, we have the inverse sine, so go to your trig button, and then inverse sine of 8/7. You're going to get a domain error. Okay? So consider the domain of the inverse sine. Remember, the domain of the inverse sine is the range of the sine. So it's the same to consider the range of the sine. Well, the range of the sine is from -1 to 1. And so this here, we get a domain error. This means that this value is undefined. Okay? So no such angle exists where the inverse sine where we have the inverse sine of 8/7, or where the sine is equal to 8/7. Okay? I want to consider why this is the case. So if you have a different color, you can follow along with me. I'm going to choose blue. Let's consider that part where we have the inverse, or the sine of b is equal to 16 sine 30 over 7. So that would be the second step right here. Consider this step right here. Well, this reduces to sine of b is equal to 16 times a half over 7, or sine of b is equal to 8/7. Well, we know that 8/7 is greater than 7/7. It's greater than 1. Well, the range of the sine, the output, should only be between -1 and 1. Therefore, this output of 8/7 can't possibly exist for any value b. Okay, so it is undefined. The inverse sine is undefined. So the range of the sine is from -1 to 1 inclusive. Okay, 8/7 is outside of the range of the sine. Okay, therefore no triangle exists. Okay, case 2. 2 triangles exist. All right, so back to my original color. In triangle ABC, again, a measure of angle A is 30 degrees, side length A is 10, side length B is 16. Solve for the measure of angle B. So the sine of 30 degrees over side length A, 10, is equal to sine of B over 16. This is our law of sines equation. Okay? Multiplying both sides by 16, we get that the sine of B is equal to 16 sine of 30 all over 10. And again, we can reduce that. So 16 times a half over 10, we have 8/10 or 4/5. Okay? So then, remember, the sine of b equals 4/5. So b is equal to the inverse sine. You take the inverse sine of both sides. The inverse sine of 4/5. Okay? Let's go ahead and plug that into our calculator. Now, 4/5 is less than 1, so we are expecting an answer here. So hitting the inverse sine of 4/5, we get about 53.130. Okay? 53.130. So yes, indeed, this is a solution, but this is not the only solution. Remember, the inverse sine, when we talk about the inverse sine, the range of the inverse sine is from -pi/2 to pi/2, or from -90 to 90 degrees. This is only going to give us solutions in quadrants 4 and 1, or those negative and positive acute angles. So we have to consider the obtuse angle. So in order to find the obtuse angle, where the reference angle is 53 degrees, this would be in quadrant 2. Okay, we're looking at where the sine is the positive 4/5. So therefore, a reference angle of 53 degrees with a positive sign is going to be in quadrant 2. So the supplement, I'm going to use a different color here. We must consider the obtuse angle, which is the supplement. Okay, so the reason why we have to consider this is our calculator, remember the range of the inverse sine, our calculator only gives us one angle measure. It's only going to give us one solution. But we need all the solutions, all of the possible values for B that satisfy this criteria for this triangle. So the supplement here, if we say the measure of angle B, this would be equal to the supplement, or 180 minus 53.130, which this is equal to 126.870. Okay? So now, is 126.870, does that give us an actual triangle here? So then we have to consider the third angle. I know that angle A is 30 degrees. Angle B would be 126, so this would be 156 total. So then angle C, so the measure of angle C would be equal to 23.130 degrees. So yes, all three angles are defined. These work. So this obtuse angle also works. Okay. All right, so in summary for this one, we get an answer for an angle, but we have to consider the supplement and see if that forms a triangle. Okay. Let's try one more example. Case 3 is where one triangle exists. Okay, again, we have side-side angle. So using the law of sines, measure of angle A is 30, side length A is 20 now, and B is still 16. Solve for the angle B. So we have sine of 30 over side length A, 20, sine of B, which is we don't know, and then over side length B is 16. Solving for sine of B, we multiply both sides by 16. We get sine of B is equal to 16 sine 30 over 20. Well, we know 16 sine 30 is 16 times a half. Sine of 30 is 1/2. So we get 8/20, which reduces to 2/5. Okay? So then solving for B here, we get B, taking the inverse sine of both sides, we get B is the inverse sine of 2/5. This is within our range of the sine, so this is okay. 2/5 is part of the domain of the inverse sine. So let's plug this into our calculator. Inverse sine of 2/5. And we get 23.578. Okay, so this is one answer where angle A is 30, B is 23.578. Okay, this would imply then that the measure of angle C, not that we need this, this would be equal to about 126.422 degrees. Okay. Okay, but now let's consider the supplement. Just like the last case, I want to make sure that there's not two triangles here. So check the supplement. Okay. So if we check the supplement, let's take what we got for the measure of angle B, and we'll solve for the supplement. So 180 minus 23.578. This is equal to 156.422. Okay. Now let's consider whether this defines a triangle. I notice that we have 156.422, and I notice that we have 30 degrees from the measure of angle A. So if we were to add only those two angles, we would exceed 180. And we all know that triangles, the interior angle sum is 180 degrees, no more, no less. So this does not define a triangle, so therefore the measure of angle B cannot be 156 degrees. Okay, so let's summarize. The measure of angle A plus the measure of angle B is greater than 180. And to be extra clear, that 30 degrees plus the 156.422 degrees is greater than 180 degrees. Okay, so therefore, the measure of angle B cannot be equal to 156.422. Okay, we exclude this answer because it does not define a triangle. Therefore, our only solution here is where B is equal to 23.578 degrees. Okay? All right, so in summary, we have three cases where there are zero triangles, and that's if the value of the sine is out of the range. Okay? Remember, the range of the sine is between -1 and 1. Or in other words, if the domain of the inverse sine is it's out of the domain, right? We have one triangle if the supplementary angle does not yield another triangle. So when we check the supplement, the angle sum is greater than 180 degrees here. That's what we had over here. And then we have two triangles if the supplement yields another triangle. Therefore, the angle sum is equal to, or the first two angles are less than 180 degrees. Okay, so then you can define that third angle, and then it's going to be equal to 180 degrees. All right? So we're going to get a whole lot of practice on this. If you have questions on these notes, this has been Law of Sines, Ambiguous case. Leave a comment below or send me an email. I can answer that as soon as I can. Otherwise, I will see you all in class. Have a great day, everybody. We'll see you. Bye.